figure 6.2.1. 6.2.1 and 6.2.2. All right. So right here, 1, 2. Critical point of this system, obviously not on the origin, but when you affect this shift, it just replaces it. Now notice the I don't want to write this with a pen, but notice here, originally XY plane. We do this shift, well, really just we're moving the x-axis over a little bit, the y a little bit, and it's in a UV plane, but all we've done is a rigid transformation. So in this new system, the critical point is 0, 0 in U and V, but it has the identical behavior. It's the same critical point, just moved over. So we can examine it by placing it at 0, 0 in the UV plane. Okay? All right. Now we can examine it. So coefficient matrix is
are we allowed to just, because by just looking at the original equation, if you isolate just the x and y's or whatever, you can, the leading coefficients are the same?
Wait, if the leading coefficients are the same?
No, they are the same as if you were using u. If you just look, like I wrote down before we did the u thing, I wrote down -1, -1, -3, 1.
I'm not sure if I'm following the question, but
I was just wondering if we could like skip the transformation to u and v.
well, we still need the matrix. We
Right.
still need this coefficient matrix
Right,
because we're going to examine what kind it is.
right. I was just saying I got that before doing the transformation. If you just look at what x and y are, the coefficients of x and y before doing the transformation.
Original?
Yeah.
Okay.
And you
Right here?
Yeah.
Negative, -1, -1.
Yeah.
3, -3, 3, 1.
-3, 1.
Are those the same?
Yeah.
Yeah, maybe. I don't like to make promises that that's always the case.
Okay.
But -1, -1. -3, 1. Yeah. Yes, they are. Well, right, but I don't like to promise that it's always that way.
Wait, but it's always going to be right.
That's last theorem.
Well, no, because you're plugging the u and the v and
Yeah.
multiply by constant. The only time it won't be right is maybe if there's
Right,
like a square.
right. Yeah, because U and V will be just a shift, linear, just left, right, whatever, up, down.
You're literally
So,
multiplying u and v.
right. So we have 3 minus X minus U. So we're going to have a minus Y minus a V. Okay. Minus 3X, that's going to be minus 3U plus 1Y, that's plus 1V. And that 3 and that 1, yeah.
Oh yeah, because always the same coefficient.
Okay. Okay, nice.
Unless they're not homogeneous or autonomous.
It's not.
Or
because-
not autonomous.
It is autonomous.
If it wasn't autonomous, it might change.
Right, and we got problems,
Yeah.
yeah.
We're not going to want to do that anyway. So.
Mhm. All right, so this is the quote-unquote, new system. It's not really a new one. We just shifted over, so the critical point coincides with 0, 0. And what would be the? Let's just write this down. A minus lambda I would be -1 minus lambda, -1, -3, 1 minus lambda. All right. So let's find the eigenvalues. The nice thing is we're not solving this. We're just characterizing the critical point. So we only need the eigenvalues, not their corresponding vectors. All right. So we take, the determinant of this. Determinant A minus lambda I. Set it to 0. So I am going to do that thing where I pull out the negatives again. This is going to be 1 plus lambda. Pull out the negatives from this, it's going to be -1 plus lambda, that's lambda minus 1. Minus, and -1 times -3 is a positive 3. All right, and so we're going to get lambda squared minus lambda plus lambda -1 minus 3, so that's -4 equals 0. All right, so what are we going to get?
Lambda equals plus minus 2.
Okay, so we get real, unequal, offset sign. What's this gonna be? Oops.
Saddle point about the point 1, 2.
Uh-huh, right. Now, once I've done that, I abandon the solution as 0, 0. It's not at 0, 0 anymore. We just shifted it over so we could use this eigenvalue method. But it's going to be a saddle point, which is always unstable. Saddle point at the original was 1, 2. All right. So there was another example, but it's basically the same. So we'll just skip that. Save the time. Okay. Let's get out the exams.
Collective side.
Oh man, that's fast.
Well, I sacrificed. I did not grade the problem sets.